All right, I'm not even going to play around. This problem stinks.
Don't nobody go in the bathroom for about 45 minutes.
Yeah, it's pretty much that bad. All right, because what we did in class, we would get the radical on one side and square both sides, and the radical would go away, and everything was happy. That was what you did on the problem just prior to this one, if you have just come to this question from the homework. I'm still going to square both sides, but when I square both sides this time, contrary to what you may think right here, these square roots do not all disappear. All right, we're going to have to treat this thing as if it were two binomials, right? I have square root of x plus 8 plus the square root of x minus 8 times itself. All right, so this is a pretty long, ugly thing here. Now I'm going to keep over here. 16 squared, by the way, is 256. We'll go ahead and write that here. All right, so when I do FOIL on this, first, outer, inner, last multiplication, I get square root of x plus 8 times the square root of x plus 8. Now that does, in fact, make that become just x plus 8. This is where it gets ugly. So the next step, square root of x plus 8 times the square root of x minus 8, I can't do anything with that. Right? I can't combine those. Now I can come in here if I want to. When you multiply two radicals, you can combine them together inside one single radical. That's permissible. We can do that, but I can't do anything else with this. And when I do the inside, I actually get the same result, right? Plus the square root of x plus 8 times the square root of x minus 8. And again, I'm going to combine them under a single radical because I can do that. What I'm saying here, when I say combine them under a single radical, square root of x plus 8, square root of x minus 8, when you have two radicals like that, you can put them together. So if it was square root of 2 times the square root of 5, you can call that square root of 10. You can multiply those two together. That's a simpler example just to show you. And now my final, the last multiplication, the last term times the last term, does in fact simplify down to just x minus 8. And now I have equals 256 on the right hand side. So now I can combine like terms, and I have lots of like terms here, believe it or not. So I have x, and I have x over here. So x plus x is 2x. And then over here, I have 8 minus 8. So those two will actually cancel each other out. All right, now we have a couple of unlikely like terms here in this part. This whole square root of x plus 8, square root of x, and then x minus 8 in the radical, there's two of those, and they're the same thing. So just like x plus x is 2x, this radical plus this radical being the same radicals is 2, and we can write square root of x plus 8, x minus 8 in the one radical. And then on the far side we have 256. Alright, so now we can subtract 2x, and now we can isolate the radical. Alright, so I'm just going to write minus 2x over there. So I have 2 square root of x plus 8, x minus 8, equals 256 minus 2x. And so now I am going to square both sides. All right, now be careful here. This 2 is outside of the radical. So when you square that 2, it does become 4. But now when you square this square root, you just get the stuff on the inside. And then on the right hand side, when I square this, I'm going to use my shortcut method. And go ahead and write this out, but I'll write the steps up above for how to actually FOIL this out if you want to check yourself. So again, this is where I've actually FOILed this out step by step so you can see how I came up with this information down here. So now I'm going to FOIL the left hand side, x plus 8, x minus 8. I'll go ahead and write that down here, 4, and so that's x squared. And then these are conjugates, right? So when I do the x minus 8 and the x plus 8, sorry, x times negative 8, x times positive 8, that cancels, right? Minus 8x plus 8x. Those are going to cancel out. And then I have 8 times negative 8 is negative 64. And then I have all that same stuff on the right-hand side. I'll just not write that out to save some time and space. So now let's come back up over here and continue this problem. I have 4 times x squared minus 64. So I'm going to distribute that 4 down here. 4 times x squared, 4 times negative 64. So 4 times x squared is 4x squared. 4 times negative 64 is negative 256. And then on the right hand side I have all of that expression there that I got when I forward that binomial. Alright, so now a simplification here where I take minus 4x squared, and actually, lo and behold, you see what happens when I do that. That and that, they both cancel. So now I've actually turned something that looked like it was going to be quadratic into a linear equation. Alright, so now remember, with linear equations, we actually get the x on one side and the numbers on the other. So I'm going to take this 65536 and subtract it from the right hand side and put it on the left hand side, and that's going to give me a linear equation solution, so negative 1024x, and then when I add those two together I get negative 65,792, so I divide both sides by negative 1024, and so I'm dividing two negatives here, so two negatives make that become a positive, and I'll pull out my calculator and I'll take 65792 divided by 1024, and so I get x equals 64.25, and that is our final answer to this awful, stinky question.
Somebody open the window.